Now we reach question 6, and question 6 says, suppose that the demand curve for Garbanzo beans is given by Q is equal to 20 minus P. Now in this video, if you don't learn at least a little bit of economics, at least you would learn that Garbanzo beans is just another way or another name for chana, aka chickpeas. Yes, it is the same chana that you put in your barrel. Garbanzo beans is just a different way of saying that. This chana, it is demanded using this equation here, right? The quantity demanded is given by 20 minus P, where Q is thousands of pounds of beans bought per week, and P is the price in dollars per pound. Part A of the question asks how many beans will be bought at a price equal to 0. When price is equal to 0, we call the quantity demanded equation is 20 minus P, so this is equal to 20 minus 0, which is equal to 20. So therefore we have a quantity demanded Q, a Q that is equal to 20, but we must know that Q in the question is thousands of pounds of beans bought per week. Therefore, 20,000 pounds of beans will be bought per week. Part B. At what price does the quantity demanded become 0? Again, we call the quantity demanded equation is QD equals 20 minus P. And you want QD to be 0, so you solve for P when QD is equal to 0. So you set QD to equal to 0. So 0 is equal to 20 minus P, therefore P equal 20. Therefore, at a price of $20 per pound, the quantity demanded of chana will be 0. Part C says calculate total expenditures. So your total expenditure is calculated by price times quantity for beans of each whole dollar value between the price identified in Part A and the price identified in Part B. Recall in Part A the price was 0 and in Part B the price was 20. So you need to check for each price, each whole value price, so 0, 1, 2, 3, 4, all the way to 20, what is the total expenditure? And we will do so using this equation, where we know the quantity demanded is given by 20 minus P. So let's start. When price is equal to 0, we saw that the quantity demanded is equal to 20. Therefore, your price times quantity, which is your total expenditure, is equal to 0, because 0 times 20 is 0. When your price is equal to 1, your quantity demanded is equal to 19. Therefore, your price times quantity is equal to 19. When your price is equal to 2, your quantity demanded is equal to 18. Therefore, price times quantity is equal to 36. And we could skip a few. I mean, you should not, but I could. So when your price is $9, then your quantity demanded would be 11. Therefore, your price times quantity, which is your total expenditure, should be 99. When your price is equal to 10, your quantity demanded is equal to 10. Therefore, your total expenditure will be 100. When your price is equal to 11, your quantity demanded is equal to 9. Therefore, your total expenditure will be 99. Let's skip a few again and go all the way to the end, well, almost end. When your price is equal to 19, your quantity demanded will be 1. Therefore, your total expenditure would be 19. And when your price is 20, we saw that the quantity demanded will be 0. Therefore, your total expenditure would be 0. So we answered this question. Part C, we calculated the total expenditure for each whole value dollar between 0 and 20 for price. Now let's check Part D. Part D says, what price for beans yields the highest total expenditure? And we saw from this whole table that we have here that the highest total expenditure is equal to 100, and that happens when the price is equal to 10. So the answer for this is when price is equal to 10. And that answers Part D. Part E. Suppose the demand for beans shift to Q is equal to 40 minus 2P. How would your answer to Part A through D change? Explain the difference intuitively with a graph. So, from Part A through D, well, instead of calculating all of those things over, just take a look at this. Alright, so I'll just put a prime here so that represents this is the new quantity demanded. The previous equation for quantity demanded was equal to 20 minus P. Notice that this new equation is equal to 2 times the old equation, because this is equal to 2 times 20 minus P. Notice that this new demand curve is twice of this here, which is the old demand curve, QD. Quantity will be twice as large at each price. Therefore, your total expenditure will still be the largest when price is equal to 10. Right, so this is to explain the differences intuitively and with a graph. So intuitively, it will be twice as large, the quantity will be twice as large at each price because this new quantity demanded is twice the old quantity demanded. And with a graph, so this is the graph that you would draw. This one with A represents the demand curve in part A, which is the old demand curve. Quantity demanded is equal to 20 minus P. And let's solve for P because P is on the y-axis, and an equation of a line usually starts with the y-axis, right? The y equals mx plus b. So let's see. Let's solve for P. Price is equal to 20 minus Q. So therefore the gradient is 1. We have a gradient of, well, -1 in this case. Now for part E, the quantity demanded, and let's put a prime to distinguish the old one to the new one. This new quantity demanded is equal to 40 minus 2p. And so if we solve for P, we would have 2p is equal to 40 minus Q. Therefore, P is equal to 20 minus a half Q. Because this new demand curve has half the gradient as the old demand curve, because the old demand curve has a gradient of -1 and this new demand curve has a gradient of -0.5. Because it has half the gradient, it allows that for every price you have twice the quantity. So for example, at a price of 15, you have a quantity of 5. Excuse my bad graph. But you have a quantity demanded of 5. In the new demand curve, you have a quantity demanded of 10. Right? Also, if you look at the price of 10, in the old demand curve, you have a quantity demanded of 10, whereas in the new demand curve, you have a quantity demanded of 20. So for every price, in fact, if you look at 5, in the old demand curve, you will have a quantity demanded of 15, whereas in the new demand curve, you would have a quantity demanded of 30. So you see that 30 is twice as much as 15, right? So at every price, the output demanded, or the quantity demanded at the new demand curve will be twice as large as the quantity demanded in the old demand curve. And that's it for this question. This is the end of question 6, and I'll see you in the next one. Goodbye.